What if some of the strongest bridges on Earth were built without machines, no cranes, no steel frameworks, no modern engineering tools, and yet they still stand today because across the world there are bridges so precise, so durable, and so advanced that they challenge everything we think we know about ancient construction. Before we go deeper, stay with the journey and subscribe, because what you're about to uncover may completely change how you see human capability. Because this isn't just about bridges. This is about intelligence, skill, and techniques we may have lost. Let's begin in Rome, with one of the most iconic structures ever built, the Pont du Gard. At first glance, it looks simple, a series of arches stretching across a valley. But look closer. This structure was built nearly 2,000 years ago, without modern tools, without cement as we know it today, and yet it still stands, perfectly aligned, massive stone blocks fitted together with incredible precision, no room for error, because one miscalculation, and the entire structure would collapse. But it didn't. Instead, it survived centuries of weather, earthquakes, and time itself. Now think about that. A structure built by hand, outlasting modern buildings. Now moved to Peru, where something even more unbelievable exists, the Quesuchaca Bridge. This is not stone, not steel, but woven grass. A suspension bridge made entirely by hand, rebuilt every single year using traditional methods passed down through generations. No machines, no modern materials, and yet it holds the weight of people crossing a deep canyon. Flexible, strong, alive, because this bridge is not just built. It is maintained through knowledge that has survived for centuries. Now pause and think. Two completely different civilizations, two completely different materials, stone and grass, and yet both achieve something extraordinary. Structures that work, structures that last, structures that defy expectation. Because building a bridge is not just about connecting 2 points. It's about understanding forces, weight, balance, tension, compression, concepts we associate with modern engineering. But somehow, ancient builders understood them. Without equations, without computers, without machines. And that leads to the first big question. How? How did they achieve this level of precision? How did they build structures that still stand today? And more importantly, what techniques did they use that we may no longer fully understand? Because in the next part, we go deeper into bridges that seem almost impossible, structures built in locations where construction itself should have been impossible. Stay with the story, because what ancient builders achieved might be far more advanced than we think. What if some bridges weren't just difficult to build, but nearly impossible? Not because of design, but because of where they were built. Because across the world, there are bridges placed in locations so extreme that even modern engineers would hesitate. Before we go further, stay with the journey and subscribe, because what you're about to see may completely change how you define impossible. Because now, we are not just talking about skill. We are talking about location. Let's begin high in the mountains of China with the breathtaking Jiaoju Bridge. Built over 1,400 years ago, this bridge is not only one of the oldest stone arch bridges still standing, it is also one of the most innovative. Its design includes an open spandrel arch, meaning the structure reduces weight while maintaining strength. Now think about that. Ancient engineers found a way to make the bridge lighter, without making it weaker, a concept that even today requires careful calculation. But what makes it even more impressive is where it was built. Over a river prone to flooding, a location where pressure from water could destroy weaker structures. And yet, it survived, flood after flood, century after century. Now moved to the rugged terrain of India, where nature itself became part of the construction. Hidden deep in the forests are the incredible living root bridges. These are not built in the traditional sense. They are grown. Tree roots are guided across rivers and streams, shaped over time, strengthened as they grow, until they form a bridge strong enough to carry people. No cutting, no carving, no machines, just patience, years of guidance, generations of knowledge. Now pause for a moment. A bridge that is alive, growing stronger with time instead of weaker, adapting to its environment, working with nature instead of against it. Now think about what that means. Ancient builders didn't just fight the environment, They understood it. They used it. They turned it into part of the structure itself. And that's what makes these bridges so powerful. Because they are not just placed in extreme locations. They are integrated into them. And that leads to something even more fascinating. These structures are not accidents. They are results of deep understanding. Understanding of materials, of forces, of environment, without modern science, without advanced tools. And yet, the results speak for themselves. Because when a structure survives in an extreme location, it proves something important. It works. And when it works for centuries, it becomes undeniable. Which leads to the next question. If ancient builders could construct bridges in impossible locations, what about structures that shouldn't even be stable? Because in the next part, we explore bridges that seem to defy gravity itself, designs that appear too perfect, too balanced, and too precise to exist without modern engineering. Stay with the story, because what you're about to see doesn't just challenge history, it challenges logic. What if some ancient bridges weren't just strong, but almost impossible to explain? Structures that look like they should collapse, but don't. Because when you study certain ancient bridges, one thing becomes clear. Their precision is beyond what we expect. Before we go further, stay with the journey and subscribe, because what you're about to see may completely change how you understand engineering. Because now, we are entering designs that seem to defy logic. Let's begin in Iran, with a historic Sayosapur. At first glance, it's beautiful. Symmetrical arches, long, elegant structures stretching across water. But look closer. This bridge isn't just for crossing. It was designed to manage water flow, control pressure, and maintain structural balance all at once. Each arch distributes weight evenly. Each opening reduces resistance from water. And together, they create stability. Without modern calculations, without computer simulations, just understanding. Now move to Spain, where the ancient Roman bridge of Cordoba still stands. Built by the Romans nearly 2,000 years ago. Stone upon stone, carefully placed, perfectly aligned, no steel reinforcement, no modern binding materials. And yet, it has survived floods, wars, and time. Now ask yourself, how do you build something so balanced that it holds together for centuries? Because the answer lies in something deeper than tools. It lies in understanding forces, compression, load distribution, geometry, concept that must be perfect. Because in stone construction, there is no flexibility, no second chance. If the angle is wrong, the structure fails. And yet, these bridges didn't fail. They worked. Now consider something even more striking. Many of these bridges use arches, not straight beams. Why? Because arches redirect weight. They push forces outward, into the supports. This creates strength, but it also requires precision. Every stone must be placed exactly right. Every angle must be calculated, without error, because one mistake can break the entire system. And yet, ancient builders mastered this, without digital tools, without modern measurement systems, just knowledge passed down through experience. Now think about the pattern. Bridges that balance perfectly, structures that distribute force naturally, designs that look simple, but are incredibly complex. Because sometimes the greatest engineering doesn't look complicated. It looks effortless. And that's what makes it so powerful. Which leads to a deeper question. If ancient builders understood these principles so well, how did they learn them? Where did this knowledge come from? Because in the next part, we go deeper into techniques and methods, how these bridges were actually built, move, and assemble without machines. Stay with the story, because what you're about to discover might be knowledge we've forgotten. What if the real mystery isn't the bridges themselves, but how they were built? Because it's one thing to design a structure, but building it without machines is something entirely different. Before we go further, stay with the journey and subscribe, because what you're about to uncover may completely change how you see ancient construction. Because now, we are going behind the scenes, into the methods, the techniques, the forgotten skills. Let's return to ancient Rome, where builders created structures like the Pont du Gard using massive stone blocks. Each block weighed tons. No cranes, no engines. So how did they lift them? The answer lies in something simple, but powerful. ramps, wooden scaffolding, human coordination. Workers would gradually raise stones using inclined planes, step by step, layer by layer, turning what seems impossible into something achievable. Now think about that. Not speed, not power, but patience. Now move again to Peru, where the Quesuachaca Bridge reveals a completely different method. Here, nothing is lifted, nothing is carved. Instead, it is woven. Grass fibers twisted into thick ropes, ropes braided into cables, cables stretched across a canyon, anchored into stone. Each year, the entire bridge is rebuilt, by hand, as a community. Now pause. This isn't just construction. This is tradition. Knowledge passed from one generation to the next. A living method. Now consider something even more fascinating. Ancient builders didn't rely on perfect tools. They relied on repeatable systems, techniques that could be taught, copied, improved over time. Because when you don't have machines, you need methods that work every time. Now imagine coordinating hundreds of workers, moving stones, aligning structures, maintaining balance, without modern communication, without precise measuring tools. And yet, they achieved accuracy, because they used what they had. Simple tools, plumb lines, water levels, ropes, shadows. Nature itself became their measuring system. Now think about what that means. They didn't just build structures. They built systems of knowledge, systems that allowed them to repeat success over and over again, and that's why these bridges exist today. Not because they were lucky, but because they understood what they were doing. Which leads to the final question. If ancient builders had such advanced understanding, why did we move away from these methods? Because in the final part, everything connects, and we uncover the real reason these bridges still stand, and what they reveal about human potential. Stay with the story, because what ancient builders achieved may not be lost. It may just be forgotten. What if these ancient bridges are not just structures, but proof of something we've underestimated? Because when you connect everything, the materials, the locations, the precision, and the methods, you begin to see a pattern that is impossible to ignore. This wasn't primitive. This wasn't accidental. This was intelligent design. Before we reveal the final truth, stay with the journey and subscribe, because what you're about to realize may completely change how you see human capability. Because now, everything connects. In Rome, the Pont du Gard still stands after nearly 2,000 years. In Peru, the Quesuachaca Bridge continues to be rebuilt using the same ancient techniques. In China, the Jiaoju Bridge has survived floods and time. In India, the living root bridges grow stronger with each passing year. Different cultures, different materials, different environments, but the same outcome: durability, function, longevity, and that leads to the final realization. Ancient builders didn't just construct bridges. They understood them. They understood forces, balance, tension, compression. They worked with nature, not against it. And that's the key difference. Because modern construction often focuses on speed, efficiency, mass production, but ancient construction focused on something else: longevity, sustainability, adaptation, structures built to last, not just to function. And that's why many of these bridges still stand today, while some modern structures don't. Now think about that. Thousands of years ago, without machines, without advanced technology, human created structures that still work, still stand, still inspire. Because intelligence is not defined by tools. It is defined by understanding. And ancient builders had it, which leads to one powerful thought. What if we haven't advanced as much as we think? What if, in some ways, we've moved away from knowledge that once made structures stronger, simpler, and more connected to the environment? Because these bridges are not just part of history. They are lessons. Lessons in design, in patience, in understanding, and in what humans are capable of achieving. So the next time you cross a bridge, remember this. You're not just walking over a structure. You're walking over centuries of knowledge. If you want more hidden engineering secrets, ancient technologies, and mysteries of the past, make sure you subscribe and stay with us. Because the deeper you look, the more you realize we've only just begun to understand what came before us.